Everybody, I can talk without microphone, I think. Okay, yes. So welcome to this panel. SDN is dead. Long live NFV. It was planned to last 1 hour, but we are half an hour late. So I think it's not the duration; it will be the intensity that counts. So if we try to keep it a little bit shorter, maybe we can save some time for the rest of the day. So the panelists, here we have Yoshiro Nakajima from NTT, we have Diego Lopez from Telefonica, Kurt Beckman from Brocade, and Hagen Voisner from BSDN. And I'm Stefano Solzano from University of Rome. So just a very, just a slide to introduce, and then I will leave the floor to the panelists. This is a possible interpretation now that we have NFV at the peak of its expectations, and we have a lot of research projects ongoing. Maybe we have SDN, and in particular, not the general idea of SDN, maybe for example, the open flow protocol, the openness of it, maybe in a slight more down phase, let's say. I mean, and this is for discussion. Is it true that this is the situation, or maybe not? And what will happen, and what is the relation between NFV and SDN? Just to give you an idea on how pervasive now NFV is among the research projects, we have recently launched the 5G PPP projects, and 6 of them explicitly mention NFV. I mean, in their one-pager, they deal about NFV. So a lot of people, I mean, the whole 5GPP budget is 100 and something million euro. So a lot of budget from the European Commission in research is put over NFV. I assume that some others deal with NFV, even if they do not mention it in their one-pager. I'm working in superfluidity, and we did not mention NFV, but we are working with NFG. I think also Hagen, maybe his 5G EX, I think it is about NFV somehow. So I think that everybody here is working with this. So
acknowledge it. Don't deny it.
Don't deny. Don't deny.
We all know.
You're doing. You're doing. So this is the point, and let's try to understand if this effort are well put, and what are the concrete expectation. What will happen. Let's try at least to discuss this. So as a first speaker, I will give the floor to Diego. Where is the?
I think it's on that side.
Okay.
I guess.
Okay. This is Diego.
So I will be very brief, because among other things, what you are seeing right now is essentially what the same kind of slides I was showing yesterday, only that it has no the ETSI corporate aspects, and I have looked for a couple of figures to illustrate the whole thing. Basically, we are not talking about something that is SDN and NFV are the same essentially. If you look at it, probably we're talking about different waves of a general movement about making networking sexier, or making networking programmable, or looking for a convergence of IT practices and networking practices, whatever we call it. But essentially is that there is no succession. There is no old king and the new king coming. It's simply that we have several waves. This is probably NFV is the second wave. Very likely there will be, hopefully, a third wave and a fourth. And well, we will have to deal with them and keep the whole thing united. Next one, please. It's just and something that we cannot forget, and this is something that I try whenever I'm talking about networking software in networks, etc. It's about that the old mentality about the boxes is something we have to somehow lose. Still. And I'm the first one that still tend to think in terms of boxes. And what we had to have in mind is a little bit like this Newton disk, that is precisely something that when you move it becomes completely white, because everything is blurred. And it's about thinking software. It's about thinking that you have to deal with things that are multi-language, multi-tenant, multi-thread, multi-whatever. And not this my box when I have my control, when only I have access to the CLI, etc. And something that is very important is about having the human in the loop, in the development loop, not so far in the configuring or maintenance loop. It's having the human in the development loop. Well, as I said, it's about having a continuum of solutions, a continuum of approaches, and not thinking that right now somebody that is writing software in Java cannot care less whether the libraries he's calling are based on C or we're writing even in Visual Basic. I doubt, but anyway, could be. This morning I was really astonished to hear that these these guys, these Broadcom guys were making the TTPs with Excel files and Visual Basic. Come on, it's something that is Broadcom. Yeah, no, Broadcom. But it was a little bit frightening, you know. But anyway. So the idea is precisely this, and well, consider I am very much insistent with these intent-based interfaces, but I must say I am in love with them. So it's something that I'm sorry. And I think that it will be probably the coming buzzword. In a couple of years, we will be talking about NFV is dead, long life intent-based networking or whatever. Well, it's because there are successive waves of a general phenomenon that I am confident is here to stay. That's all.
Thank you. Thank you, Diego.
Thank you for giving my talk. I was going to say most of that.
Really?
Yeah.
That's good.
So, I can, does not work.
Yeah, I would not have been as articulate.
No,
Oh, I'm next.
Yeah, if you are related, then
Can you put up the Gartner hype cycle?
oh yes, okay.
Yeah.
Okay.
So yeah. In fact, I agree completely with Diego about that. NFV is just in some sense, a variation on SDN. I mean, the core part of SDN, to my mind, is that decoupling of control from the data plane, so that you can purchase them separately. It's much more so that the buyer has flexibility, and you want to be able to. That really will accelerate innovation in a way that is necessary. And then sort of a secondary thing, depends on who you ask, is the programmability. Obviously, NFV is about programmability. So you can see how they're really just, it's like almost generational shift. And at the same time, we still need basic hardware forwarding elements. You can't forward everything with a server. That wouldn't make good sense. But if you look at this picture, sometimes I think, when I'm in a bad mood, I'll tell people that are involved with OpenFlow that even Gartner acknowledges, if you see other versions of this picture, some technologies don't make it and they fall down. And so there may not be a plateau of productivity. There's no guarantee that you get to recover.
Yeah,
that's right. You can fail. So just be careful. If we're not careful, we'll be one of the failures. I say we because I'm still pretty intimately involved in OpenFlow and SDN. But really, I think they are exactly as Diego described, that they work closely with each other, and that we mostly need both. There are a few use cases where you can use SDN and you don't need NFV, and mostly those are the use cases that you see deployed now with OpenFlow that don't have NFV yet. And the big interesting stuff is NFV. I think one of the reasons why we're seeing some disillusionment actually is, in some sense, NFV is a distraction from SDN, and a lot of energy has moved toward NFV, which is maybe appropriate, but I think it has impacted SDN as a consequence. So, I mean, you could say impacted OpenFlow. The other big one is that if you go back 2-3 years, there was a huge amount of confusion in the controller space, and SDN was really focused on the switches. Controllers, we were saying, oh, well, there'll be a de facto controller. And it took kind of a while, and then finally, big investment in Open Daylight. ONOS came along quite a bit later. I mean, it sort of existed, but it wasn't open until, what, last December or something? And so then ODL, Open Daylight, came into the picture, but it couldn't do anything for quite a long time. It now is only recently becoming an interesting controller. So for about 2 years, I would say OpenFlow was kind of stalled due to controller issues. You know, okay, suppose you want to build an OpenFlow-based network. What's your API? Who knows, right? So it's only recently that kind of the relationship between SDN and NFV is becoming more clear. The controller picture is coming more clear. As I mentioned in my talk this morning, for those of you who got up this morning, that there are some problems actually, of course, in OpenFlow that were slow to be addressed, and those will be addressed. I mean, we're working on them, right? So if we hope to be able to make it back up to the plateau of productivity, we have to solve those problems. And there actually is quite a bit of progress on those. As if you heard me speak, you understand my opinion about that. So this is all just going to shift, I think, in the SDN space. But at another level, I really do think, you know, the bulk of flows are going to be going through NFV in a year. Maybe not the bulk in a year, but many in a year, and in 2-3 years, the bulk will be going through NFV. SDN will be in the picture, but it's kind of about NFV.
Maybe if you have some direct questions to the talk, or of course we can take questions later on, and if you have just direct questions. Okay, now, so I can leave to Yoshi here.
So I'd like to mention about the SDN thing and NFV from the development point of view. So maybe you know we are a good chance to changing the wave of networking. So that means if you develop program services by yourself, maybe you have a chance to move to the next step. So maybe someone knows NTT has already deployed the OpenFlow switches in the real production network. It's a very strange things, and basically the OpenFlow switch is a layer 2 functionality, maybe. But we apply the OpenFlow switch for the gateway switch that allows the routing information to propagate the route to the wider network using the stack of the Python-based system to integrate other management system. That is a very common use cases of our carrier system. And so I'd like to mention about the architecture of the OpenFlow controller. So maybe someone very interested in very centralized management system. It's like OpenDaylight or NOS try to integrate the more concrete and the more scalable and more high available controller system. But in our development experiment, we think so intelligence should be moved to the edge, not in the centers. So we can leverage. So we just provide the OpenFlow controller for just controlling the switch forwarding plane, but we can leverage many novel distributed middleware such as this databases and the queuing system and other. So we think SDN philosophy is to how to integrate the switch or networking to the other system as a component. Okay. And so we have several experiments using the OpenFlow switches, but it's a so I think OpenFlow is a very good protocol, but it's very primitive. So we need kind of a more flexible or programmable interfaces for users, not for the developer of the switch agent or something. And also, we have to care about the management protocol. So that means, yeah, if you develop the switch or networking management system, you have to write down the expects-based script. It's a nightmare for me because if you upgrade the firmware, I have to rewrite the source code to adapt the new way of error message or alert or everything. So we want to realize a more modern way for networking. It's like a REST API or a JSON. And maybe for the next step of the NFV, so in some use cases, we need fine-grained flow control. So maybe OpenFlow will be good option. But in some automation deployment tool for the cloud system, maybe layer 2 or layer 3 networking is enough. Maybe so everyone said architecture is very important, but we think so how to improve the API for the customers. So that means so we can modify the source code for on demand. So that means we can do a lot of so we have a lot of things to do the SDN and for the NFV or 5G system. That's all.
Okay, so we can have a final introduction before the discussion.
I think I can do it from here.
Okay.
Since I've been obviously invited to speak about the death of SDN, I can share with you some of my disillusions. I didn't prepare any slides because I was largely fixing some stupid bugs of my demo. Malformed packet-ins. This is 2015. This must not happen anymore. Come on. No, the point that I want to make. This is still software. We had a malformed packet-in because somebody came up with a new boost library, and I had it in some commit somewhere. This will always happen. And I think we have to make sure that the interfaces that we have when we're splitting control from data will need to be trackable. We will need to really understand what's going on. I think precisely for that, a REST interface looks good to start with, but as it doesn't carry any semantics, it's actually really hard to understand what is happening across this thing. So in that sense, I would rather still be on the side of saying we should improve OpenFlow as the unique interface, as the only interface. And I had one question to you before about the role of OF-config, because I mean there's a lot of things that OpenFlow is missing. I don't see a lot of energy at the moment in OF-config, and my opinion would be that the TTPs that you were mentioning would be natural part in OF-config, but I don't really see where this is going, and I would like to, let's say, vote for the reduction of interfaces to something close to 1. But that will make it rather heavy.
Yes. So I think that means you mean the interface towards the switch. So you want to control because then I think you need to build something higher level, and maybe that was the intent base that was referring Diego. So on one end, I think that there is the need to understand how we talk with the switch, and then of course how to build something that it's more useful to the upper layer, and this is why maybe the intent can be very, very, very interesting. I mean, I think that there will be maybe different types of people. The one that will be dealing just talking with the switch, and the other that, of course, are not interested and just want to have an high-level view. And maybe the NFV is more close to this high-level view from the point of view of service design or something like this. It is an interpretation of what you have said, or?
Definitely, for what regards the intent-based interfaces, is there an intent? Well, I'm in this Unify project. I'm always like coming up with my use case of I want to have something that's called a home LAN, like a layer 2 switch and a DHCP server integrated, and I just want that to be deployed on a CPE. And now that is something that we are actually using NFV for doing that, but that still, even though there is basically the service has a name and people are understanding this name, so there is some fuzziness in it, because everybody will have a different interpretation of it. But we are using computers for quite some time now, and we are actually used to what I can expect from GCC, I don't know, 4.8.2. I somehow know what it is, even though it only is a name. And I think this is, we shall try and maybe unify those two interfaces, the network interface and the service, or say the more complex service interface, into one that would clearly be like intent-based. And I think it's actually quite like with Atrium and the TTPs, that should be a good step forward to at least get a better grip on the hardware. But then, for me, it's easy to understand what a layer 2 table is most of the times.
Yeah, it's definitely. The layer 2 table is much less complicated. I mean, it's certainly, you know, either physically bounded geographically, or at least virtually bounded in a way. It's just a very small world compared to, you know, the V4 world, which is much smaller than the V6 world. So certainly layer 2, I think, is a simpler picture. I agree with you about the problems with config. In the early days of the work of the forwarding abstractions working group, we said, oh, well, we would like to be able to negotiate these TTPs between the controller and the switch. As you say, the architecture has evolved a little bit. I don't know if negotiation is so important, but they said, oh, well, you should do that. You should use OFConfig for that. And I hadn't really looked at OFConfig. Okay, great. Invest several months in working out the negotiation in OFConfig, and then come to find out adoption of OFConfig is essentially 0. It's not a required protocol. If it's not required, why would I do it? And if most people aren't using that, well, why would I code to it? Because most switches don't have it. And so it's sort of this, it's a little bit like the Forces effort. You know, somebody invested a lot of time, but nobody's doing anything with it. This is a problem. You know, sort of a standard that's not adopted is nobody's going to use it, chicken and egg kind of a problem. There is some wrangling going on within the ONF about how we solve this. I think there's a bias, or I should say a camp, that is interested in, let's unify this. Why should there be 2 protocols? We don't have a unified information model. That's actually been a big problem. So, you know, when somebody says, say, VLAN or even port in OFConfig, does that mean the same thing as VLAN or port in OpenFlow? Well, mostly. That's not quite good enough, right? So all the area you're talking about, that essentially that you can have malformed packet, right? Well, this is what happens when we're in a fluid dynamic situation where, you know, things mostly work except for when they don't, you know. So I think we're quite a ways from that maturity. It's sort of like, yeah, back when we were using, you know, Linux in the 90s or something. That was a fun system, but it wasn't, you know, production. You wouldn't run anything production on that, and that's where we are. I think we're a little bit more, maybe late 90s on Linux or something, but we have to get that other level. I do know that people are using these things, and if they use it in a very constrained way and very stable, and they use some build that was made 7 or 8 months ago and has been through a lot of tests, okay, they'll run that in production in a very constrained way. But yeah, we need to be able to move beyond that and get into a world where you can do a build and you know, because the way it was built and how it was tested and the components that went into it, that build, you know, needs a certain amount of test, but maybe it's a couple of weeks of test, and then you can say, okay, I'm ready to move that into production. Basically, Google doesn't have some 6-month delay between when they build something until they move it into production. Of course, it's always beta. It's beta for years, but it's still sort of production beta, however they do that, but it's magic. But the rest of us need to get into that model, right? We're already looking at becoming agile, but we need to get more robustness and maturity in the elements that we use to construct these pieces, as well as in that process. The process, I think, is improving, and the elements are improving, but we still have quite a ways to go. And we need to, you know, left out even of OFConfig and OpenFlow is provisioning. Provisioning is not really either of those. I mean, I would include it into management and configuration, but it's not either of those protocols. So now you have to think even beyond that.
Where do you put it?
But the TTPs are less negotiated now in my current thinking. It's more, once you understand what the device is, you'll probably understand what the single TTP is that it probably supports, unless it's a NPU. NPU probably will be support. We do have an extension that we're developing for negotiating TTPs within the OF switch protocol itself, so that we don't rely on OF config. But that doesn't fully answer the question, right? It sort of answers it for TTPs, but we still need to have a config protocol. There's a debate between, do you go OVSDB, which is now appearing in a lot more places than OF config? Well, why don't we just go with, people vote with their feet, right? Why don't we go shift from OF config to OVSDB? A big debate about that. Or support both of them. Let OF config or OVSDB sort of be an underlying protocol, and we have semantics above that, which seems completely achievable, but we'd have to spell that out, and we haven't done that yet. So I'm focused on my own problems, but pretty soon that will become an obstacle for the progress that we're trying to achieve, and I'll pay more attention, and I think other people will too.
A couple of reflections about this. This morning when you were talking, something that came to my mind was somehow the analogy of the first OpenFlow 1 being like like it is right now, it's an interpreted language, something that happens by the controller is taking decisions one by one, and it's sending them the flow mode commands and all the like, and that if we move in the direction, whatever, call it TTP or call whatever, I don't know how to call it, pipeline insights or whatever, should be closer to a compiling environment. So because the controller should know in advance which are the pieces it's talking to, and would prepare certain commands that probably would not be necessarily the same commands that would issue in other cases. But providing a consistent API on top of for the applications. That could be but if we go a little bit further in that analogy, the situation is the same when it comes to configuration. When you have a compiler, apart from the compiler, you have two phases. Well, you have a post phase when you compile, which is the linking, and you have to link, and the link is a phase in which you instantiate the real thing. And on the other hand, what is the configuration control, the version controlling and everything, is completely, goes in parallel with tools that are related but are not the same at all. I mean, in the good old days, we used to use make. Now then, I know that people started to use something called Maven, and apparently there is something else that I'm not familiar with at all. And that's, we still lack this make and Maven and things like that for networks, for programming networks. What we do have, we are right now at the level, my impression is that we are at the level of the old basic interpreters, and we had to move a little bit forward. We are moving towards having the first C compilers or whatever. P4 sounds very promising and things like that, but we still lack this tooling to build things. And well, probably Professor Carl at the bottom of at the back of the room can tell you, we are precisely addressing this with some ideas we have in a project that is called NetID, and we are working in that direction, trying to make some experiments of how you can integrate SDN tools in a general software development environment. I'm playing with the idea of making a making a Maven, and not caring, or well, at least the one who is developing not caring about how this is implemented. That is, again, is very important. When I'm writing Python, I cannot care less about how the interpreter makes its decisions. And this is something that still we are not used to. And second point is about, well, when you mention Google, and this is something that in industry, I guess at least operators are obsessed with Google, Facebook, and all the like. Well, I wish we could have two things. One is the same regularity or homogeneity in the infrastructure they have in Google. Google, when you say, no, they have made SDN on a WAN. Well, they have connected 17 data centers, come on. 17 data centers is something we have, well, we had the double of data centers here in Bilbao, only. So what are we talking about? We have the whole Google universe here in Bilbao, in terms of complexity and the kind of stuff that you have to connect. And second, they are extremely lucky of not having regulators on top of their shoulders. That whenever you decide to take a step in a certain direction or the other, there is somebody telling, no, hold on. We have to talk about keeping the competition open. We have to talk about fairness. We have to talk about, and that makes things much more difficult. And from time to time, even funnier, but not always.
I mean, you make a very good point, and often when you use Google as an example, you're trying to make one point, but it's interpreted in some other way. And I don't mean to say that Google's amazing. I mean, they sort of are amazing.
They are, for sure.
They are sort of amazing. My daughter actually works there. She's been there over 10 years, and I remember when she joined, and I thought, well, I hope they're still around next year. You know, so anyway, that I have a different perspective on Google because I've been pretty close to them for a long time. But my point is that Google is good as an existence proof in a lot of cases. So they can demonstrate that, yes, there is value in SDN. It's not, yeah, they can do amazing things. They also have amazing control over all their applications. They're not running a bunch of code that someone else wrote. And so when they're, from a hosting perspective, they don't have to host all this variety of software that doesn't tell you what it's going to do. It's all very amazingly done, and it's running on Google's version of Linux. It's not actually some version of Linux that you go down and get at your store. So you're quite right. You know, be careful what you say when you're talking about Google, to be clear what you're trying to suggest, or the point that you're trying to make. So partly the existence proof about that it is possible to run a complex system that's evolving rapidly in a sort of agile development environment. They do that, and it's pretty remarkable. Yeah. And it's culturally really strong, and they tell us some of how they do it, but not everything. You know, they're careful about that. They are kind of good public citizens to a point. And then they don't tell you.
And they are the perfect example of something that I have hated, I have learned to hate for a long time, that is outsourcing. Google doesn't outsource almost anything. They do everything in-house.
Even food.
You know, can we get some questions or comments from the audience? Yes, please.
One very basic question.
Maybe
we have the other one.
Do you hear me? One very basic question. So if I will look how we started at the beginning of SDN, we standardized basic on per service protocols on per service resolution. It was very complex and required a lot of effort. So SDN said, let us keep things simple and do it in logically centralized manner. At the end of the day, we realized that a single logically centralized controller, at least in general, cannot control the whole network. So we need to interoperate several controllers together. Currently, we already have a number of controllers that is comparable to the number of originally major switch vendors. So still, if you'll take a look, we need to interoperate these controllers, and what kind of protocols we will use to interoperate these controllers, the old east-west per service protocols. So a lot of things happen, but nothing looks like changed. So are we going in the right direction? So possibly instead of investing so many efforts in false direction, we just need to standardize possibly east-west API and just require from vendors open APIs to control, to configure FastPass instead of just control everywhere. So I understand that, for instance, Google or Facebook want to control everything, so they are investing a lot of resources to keep the whole process in the hands. So, but not everybody is interested in this. So the same level of flexibility can be achieved if I can configure the same Cisco box, for instance, through, I think Cisco already exposed a lot of, several types of southbound APIs, and significantly more richer than OpenFlow. So can you comment about it?
Who will start? It's a tough question.
I can make a comment about the last things you have said about Facebook and Google willing to control everything, and then Cisco exposing some interfaces, and so they are not willing to control everything. You see, I mean, if we go for standardizing around Cisco, which is a different whether if we follow whatever Google's path. I mean, my point is here is when you're talking about the networking software, is the same. We're talking about the same when you're talking when you are dealing with whatever based on software. Do you want something different? Run your program, write your program, run it. We can and forget about the details and probably one of the problems that we have right now in the communications world is I don't know an over-specification of many things that should be much more open if we had more flexible infrastructures. In some cases, probably we are over-specifying and we are used to that. No, precisely if you have the opportunity of running your own program, not as it was Kurt was saying that, so not or it was you, I don't know, I don't remember. Yeah, no, it was precisely about that you have a box that does things and you don't know what is inside, or because it's supposed to be compliant to a certain standard. And then it's not that clear that it's that much compliant. So probably we should try to make the exercise or specifying less and programming more. Would be much better for all of us. Much more fun. No. Don't ask, come on, go for it.
From my side, as a person that saw both internal things and external, I can say for me it looks like re-implementation of black box control plane and data plane, not in the best way for sure. Okay, so I see that basically people that currently try to implement these open interfaces doing mistakes that people did in Cisco 15 years ago. So possibly researching SDN community, this is something really strange. What I can say that research should be should lead industry, but in networking, it's something at least in SDN community, something strange happens. So I would say that the control plane implementation, abstractions of ASICs, abstractions of packet processing engines are done significantly in more in the better way that currently proposed in the best publications that I can find on best conferences. I would say the following thing. Programmable ASIC from Cisco C12K that is obsolete 5 years ago on Engine 3, Engine 5 line cards can implement any functionality from OpenFlow, from P4, and this is just because of very good abstraction of what should be hardware and what should be software. So that's basically
probably, if you allow me, just the last thing, because I don't want to make this an argument between. But if you go back to the idea of reinventing and the wheel, we are talking about something like maybe it's the boot wheels that there was in the old cars, to the tires that you have in the cars. You are reinventing the wheel. And you're even expending more, you're even spending more energy and making things much more complicated, but then you go much faster. From time to time, reinventing the wheel is not that's such a bad idea, I'd say.
We'll continue after this. Then another.
I would like to go back to the cycle, to the Gardner cycle there. And I very much agree the thought of disillusionment, at least for the SDN, may derive from the from the gap that we had between the very early enthusiastic movements around SDN, ONF and the like, and the availability of stable controllers capable of doing things. And maybe we are in the same path with NFV. a lot of enthusiasm around the specification, the POCs, and now it's time for the different vendors to set up the portfolio in order to enter the market. And so the question in the end is, how do you see this market? From a vendor side, from an operator side, from an SME side, from another operator side? I mean, is the market ready to go in the productivity, or shall we still continue doing POCs and debating about whether this interface or the other? Because in the end of the day, maybe it will be the ruler for everything.
So it's often there are several things, right? So we were just talking earlier about history and how we look back 50 years and about world history, or 70 years, and it all seems, the decisions all seem so clear in hindsight. But if you were there in the middle of it, it was absolutely a brawl. And we are actually in a brawl right now. And you think, you know, why can't we make decisions better? This is a brawl. This is most of it. It's economics. So there's going to be winners and there's going to be losers, and it's absolutely a war going on, and we're being very polite about it. If you think back, also, so I have a degree in physics and I have an MBA. I don't have an engineering degree. I don't have a computer science degree. So I'm an oddball. But I think there's probably other oddballs in the room, so I'm not the only oddball. But the reason I say that is that there's a case study done around IBM in business school, and IBM did just one of the stupidest things ever, right? When they introduced the PC, they went and used a third-party piece of silicon. They went and used third-party operating system, and then they opened it up architecturally, right? How long did it take before they were not dominant in the PC industry? And then they tried to say, well, we're going to switch to microchannel, and the rest of the world said, have fun, go enjoy that, and they were back to open PC again. That was fantastic for the rest of us, right? Because PCs were not broadly deployed, so it was basically greenfield everywhere, and off we went. And then pretty soon there's Microsoft and there's Intel everywhere, and it's Windows, and then guess what? There's this ubiquitous platform that Linux can then go be adopted on as well, right? It's just quite remarkable. We're not in that situation at all. Oh, the other thing is, in that world, when you have a computer, it's your own environment. You control the whole thing. If it crashes and burns, it's only your problem. You can have one that you keep virgin and reliable, and you can run it, and you can go experiment on your other one. Nobody cares, or only you care. Here in networking, it's not quite like that. I mean, even in university, suppose you want to do something, I mean, if you want to do something isolated, you can go in your lab, or you can do a small network, you can do a mini net. If you want to do something interesting and deploy it across the campus or even across the building, how popular is that, right? What are you going to promise me, right? So, I mean, I've heard stories about that, and then you go and deploy, and it's wonderful, great bandwidth and everything, and then when the quarter's over, you take it back away, you score a lot of points. So we're in this world now where there is no real greenfield. There's networking everywhere. There's an SLA that already people have an expectation. Many people are running their businesses. Yeah, you're not going to have any downtime on my line. So go and do your experimentation somewhere else. Meanwhile, there's all these incumbent players, and there's nobody's going to make the IBM mistake, right? Because they all went to school and they all learned, yeah, you don't make that IBM mistake. So nobody's going to hand us an open architecture. You mentioned about how Cisco has solved this before. They're not telling the rest of us. They're not going to hand that one out. Broadcom's not going to open source their chips. There's all this stuff going on. It's hugely dynamic, no greenfield. Everybody wants their data center that they built last year, they want to be able to run SDN on that data center. They don't want to replace all the gear. For one thing, they can't afford the downtime, right? They've got to be able to do some kind of transition. They're going to do it incrementally. So, we look back, gee, why can't we do in networking what we did in open compute effectively? And let's not forget that it took like 30 years for open compute to sort this out. How many WinHEC conferences were there where Microsoft and Intel told everybody else how they should build their machines so that it would all work, right? This is where we are. We're going through that kind of war, and it was actually easier in the open compute space. It's much harder right now, and we're still making progress.
So, looking a bit to the years to come and to the relation of SDN and NFV, where do you see, how things grow together. I mean, for me, it's clearly not the way it's being done today, that there is an ODL crammed into OpenStack without any feedback of the actual network status. How do you see either network controllers growing into the NFV area or vice versa?
I personally, and this is my personal opinion, I think that, can I say it? OpenStack is overrated when it comes to networking. I'm not going to talk about the cloud environment and all the like, but OpenStack has a very, very primitive network model that doesn't help in building many constructs that are essential to build a network service and things like that. Awful? Well, it sucks, yes. No, essentially, and I mean, for I have no opinion about how OpenStack performs when we're talking about cloud environments. For sure, what we need, and we are working in that direction precisely, is in building a much smaller footprint control environment and management and operation mano environment. Whether it's going to be that can be considered a pure network controller or not, because you look at how ODL is getting swollen, and it's a little bit frightening as well, because the possibility of it becoming something like an OpenStack is there. And at least they are looking at it, yes, honest, yes, there is an alternative we are looking very eagerly. For the moment, in our case, we have found when we started our first NFV deployments, we found that OpenStack was too complicated to deploy for our purpose, too limited for what we wanted to do, and too difficult to modify. And fourth, very complicated to become mainstream, because you go to the OpenStack guys and they have other problems, and I can understand. They have 1 million people asking for one thing, and then you go and you say, hey, I need this, and you feel I need this, and a big operator, you should pay attention to me, and they don't pay any attention to you because you're no more than a dwarf there in the OpenStack arena. So we went our way. We decided to make our own management stack. Is there, we're starting to play with it, it's open source. Well, let's see. Right now, it runs, currently runs on top of ODL. And we are reasonably glad of this combination, but it runs on top of a very small subset of ODL as well. In the future, if we're talking about compiling TTPs inside ODL and pushing them, could be an interesting idea. So far, we're using ODL as essentially is a software control patch panel, basically, is what we are doing. And I guess that this is the way to go. I don't believe in the one size fits all for whatever, but probably with the exception of the languages. I mean, I can imagine something like a network-oriented Python or something like that to simplify rather than specialized languages, for example. But apart from that, then at the end you have, even in Linux, you have distributions suited for each purpose. So why not? Not go that much big and make things a little bit more on purpose, because you can program them.
But as you said, this role of the software control patch panel, I think SDN gives us a lot. And if you and for sure we will require that. I'm talking about because frankly, I don't know in other cases, but I must confess that we have addressed so far in detail one use case. I mean, in detail means making a deployment, going to the real world, hitting the reality and hitting the operation guys that don't want you to fiddle with the things that pays their salaries and things like that, and dealing with the marketing guys. That's real fun. When you tell them, for example, which is something like I knew about that a few months ago, and it's amazing. You tell them that you're going to virtualize the home environment. Say, ooh, the competition is going to provide the customers 3 boxes, and we're going to provide them just 1. Where is the value for the customer?
You see, because the competition can say, hey, Telefonica is giving you only 1 box for your 60 euros, and we are giving you 3 boxes. Look, with full of lights. And the marketing guys were really concerned about that. And it's something that you look at it and you say, all advantages. No, not advantages. So this kind of stuff, we have done this with only 1 case. And for that, we only needed the patch panel. We are starting to think, for example, in security-oriented mechanisms, in which, for example, what I was talking yesterday about this connection between the tenant controller and the infrastructure controller would be required. And then we're talking about much more sophisticated environment. So, and that would imply that you will have something that is based on NFV and acting as an SDN component, for sure.
I had promised to close 5 minutes ago. No, it was interesting. I have some other questions we keep for the next panel next year in the next SDN. Yes. So that will be the.
We have all the answers.
Yeah. Next year we will have all the answers. So I think that we can close in this way. Let us thank all the panelists for their very good contribution, and let's thank you for listening. Thank you.